Okay, this is our chart for the risk of doing a bicep curl, including Crawford and Aiden. So far we have gotten, if you guys want to flip. All right, so here we have Aiden going to perform a bicep curl. So we're going to measure the horizontal location, and the way we're going to do that is Crawford is going to place the measuring tape between the both feet near the ankle and measure it to the inside of his hand. And Crawford, what do you read off the measuring tape?
About 1 foot from his wrist straight down, landed on that line.
So 12 inches.
The line to his ankle is about 1 foot.
Okay, so 12 inches?
Yeah.
Okay. So we're gonna have to convert that to centimeters. So I'll just put that in there. What's 12 inches in centimeters? Is that 36?
2.4 inches. 2.1 inch is 2.4 centimeters. I don't know.
Inches to centimeters is 30.48. So we're gonna write that down in the first box.
30 point what?
48 centimeters. Okay. So we looked at the lookup table and it is 0.83. Now we're gonna move on to the VM. Now we're gonna be measuring the vertical. We're doing it. We're doing it from the knuckles, middle of the knuckles, all the way down to the floor.
44 inches.
And we've got 44 inches. And that converted into centimeters. $111.76. And was that on the lookup table?
I'm not sure because it says, wait, what? 111?
Yeah.
So that would
It'd
be,
be like 1.
yeah, it'd be like 1.
Okay. So we looked at the lookup table and we're going to be writing 0.89. For the next step, we're going to be doing the distance, and that will be from where the curl started until where the curl finishes on top.
Where's 44?
Okay, so we're going to be starting at 44 inches. That's where his hair was placed last. And we're going to be doing the travel distance. So he's going to start the curl right now. And we're going to see where it ends at. Where does it end?
About 59.
59. So we're going to do 59 minus 44 and then convert that into centimeters and put it into this chart. So 15 is 38.1
Oh, wait.
38.1 centimeters.
38.1.
Yep. And now once we look at the chart, it will be so 40.93, yeah. Now
Are
we're going.
these just supposed to be like drop?
Yes.
Yeah, rough estimates.
It doesn't say like, yeah.
Standing stationary and not twisting at all, it'd be 0.
Right angle. And then we also be 0 on the local table, right?
Lookup table would be.
Let's see. 0 is 1.
1.
Yeah. Perfect. Okay, he's going to present a bicep curl, a proper bicep curl. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. and that was the set. And for time between lifts, for 1 hour or less, with 5 seconds in between, it will be 0.37. Oh, you wrote it down? Yeah, I heard you wrote it down. So now all we're gonna do is the CM, which is the coupling measurement. And he had you wanted to show the grip on it one more time? He has a proper grip, very tight, very secured. So I will give this a good grasp. So it'll be a standing, so it'll be 1.00. So as you can look at the chart, in the actual measurements, we got 30.48, 111.76, 38.1, all the centimeters. We have 5 seconds. We have no angle because we didn't use any torque or twisting. And we have a good grip. So this is our actual measurements that we're gonna multiply.
Typing it in.
So from the chart, we had to put it out and multiply it out to get the RWL. This is the constant, and we just put the lookup table numbers out in the equation. And now Crawford's gonna figure it out. 23 times 0.83. Oh, I didn't reach that side. Times 0.89
Times
0.93
times
0.37
700 times 1 times 1.
So we have gotten, the number we got from this equation was 5.8. So we're gonna grab the lifting index, which is the weight that we use, which is 10 pounds. So now here we have the equation, and we got the answer of 5.8. So we have to change the pounds into kilograms for us to get the lifting index.
Right? 4.5
Mm-hmm.
kilograms. And then
Now we're gonna do that over 5.8. And that will be, here we get out of that, 4.5, 0.77. I'm just, that was great. So as you can see, it is at 0.77, which is very low risk, which is very common because you're doing a bicep curl. You should be able to do bicep curls for a long period of time without having any serious effect. So now we're gonna change his grip on how he does the curls, which is a coupling measurement. So we're not gonna change any of the measurements. All we're gonna do is change the CM. So just go ahead and hold it by your 3 fingers. And I think that's very poor grip. And that will be a measurement on that would be, where is it?
what's the lookup table number for that?
I don't know, I'm trying to find it. Where's it at?
Oh, that's not the lookup table, I don't think.
Where's it at?
It's that, yeah.
So for pour, it will be 0.90 standing.
0.9.
90, yeah. So you're gonna have to put that in the equation.
Instead of one of these ones.
Yeah. And now you have to.
Now I gotta type it on. Fire this up.
What we got, Crawford?
5.2.
So 10 over 5.2. Now we're gonna be doing the change in the equation, which is the coupling effect. We did a very poor coupling, so it'll be at 0.9.
So it's
0.2. Since we already changed it to kilograms, it would be 4.5 over 5.2, and that gets you to 0.86. So as you can see, it did go up, it did increase the risk, but if I'm not mistaken, it is still very low risk. So even though it is very low risk, I would still properly do it the correct way, holding it with a firm and secure handle. And so this concludes our bicep equation for Niosh lifting, and this is Jason in Crawford. Have a good time.